Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and we're in my job shop. Who thought we'd ever pick up on Pearl again, huh? Well, that one shaft we've been working on is complete, and now it's all about assembling the main gearbox on Pearl. Last weekend I went ahead and I took the two boxes off of my shelf here and moved the shelf itself because I didn't want no head knocking room. Okay, so we're fully open all the way around here, and I've got a few of the things off. I got the top cover off, the rear cover off. All right, I tilted the camera up over the gearbox here so you got a good look in it. I did have to wipe it out. It was dusty and stuff in there. The shifter for this shaft line and the shifter for this shaft line, the two shafts are in here, and both of them are prepped and ready to rock and roll and ready to assemble. So we got to look at our other components that we're getting ready to install in here. All right, I got some of my items all painted and ready to go that pertain to putting the covers, and like this cover here is going to be the adjusting in for the thrust on that one shaft. The one bearing race on the forward side is in a cup and a flange cup, so it's held in there. It doesn't have another seal on the other side. It's open to the rest of the gearbox. But this end here is the outside of the back of the gearbox, and this will be shimmed to give the thrust. Here's the inlet or input shaft. This is the output shaft for the feed side. This is the cover that you see on the front of the headstock. Another cover on the front, another cover. Here's our two handles. Where the plating had come off of here and it was a little rusty, I just took and polished it up with one of those felt wheels. And then I just masked where I wanted to mask it. Same thing on this one. I didn't hit quite as much as I should hit it. I'll probably hit it again. The main thing is you want them smooth to the hand. And then after a while, yeah, right there a little bit, it'll need some right there. But after a while, it'll get smooth to the hand. Depends on how much you use your little lathe. Started doing a pre-assembly on our gears. So these are the two gears that roll freely, and then when the cog shifts into them, it connects that gear to the shaft, or this gear to the shaft, and then these two gears are taken off, and then they're shifted in between on the next shaft in line. All right. But we brought it over here, set it up in our jig, because our jig is over here and it's set up. And what I'm checking is I got pretty close to 25 thousandths. They're both exactly the same. My concern was that excess or was that by design? This gear and that gear I pressed all the way on because they were tight to, you know, the last eighth of an inch or so. I pressed them in the arbor press, so I know that they're up against the shoulder, and I don't think it's a coincidence that both of these are exactly the same or within a thousandth of each other. All right, so now we got to go over to the bench, and we're going to just double check and make sure that our shoulder lengths for the spline and shoulder lengths for these two gears out here are exactly as per the sample shaft. All right, you can see I've cleaned up this bench here. This is all the hardware for the first shaft already cleaned out of the tank, and sitting here waiting. I've deburred everything that I need to. There are a couple keys that we need to make up for the shift forks there, because I took out the keyways that were in those, and I had to rotary burn and punch them out. Because I wanted the bore clean. I sandblasted them and cleaned the whole inside of the bore so that they'd slide on those shafts that you saw installed in there. Everything has got to go down in there and go together, not go together. All right. This is the shaft that you just saw with the gears on it. Okay, the first thing I did was just reconfirmed that these three dimensions here are within 1/1000. Then I confirmed that that was 5 inches 1/1000 to 5 inches 3/1000, and this one here is 5 inches 10/1000. So there is 10/1000, and then combination of measuring that shoulder, this shoulder, like this, and I found that it is, this side right here is 10 long. Okay, that's not enough to tell me that I got 25 thousandths clearance on those two gears when everything is assembled on there, and that it's even. Okay, so what I did is I looked on the inside of the cog that goes against that shoulder right there, and you can see the wear. Now they're not both wearing exactly even. Okay, the one that is or goes against the 10/1000 long shoulder is actually close to 30 thousandths in depth, and the other one on the other side is actually close to 10 thousandths in depth. So they just happen to both give me within a thousandth of 25 thousandths of that play. So now in my head I got to figure out what I actually feel should be in there, and no less than 2, no more than 5 is what I come up with. So what I'm going to do is I'm going to set these two gears up, and and I'm going to go ahead and skim this clear or clean, you know, this whole surface right here, and then I'm going to make 2 thrust washers that will set into this area right here and give the diameter of that thrust washer is not going to be any larger than this diameter right here. So the thrust washer is just basically going to fit between this face right here and this face right here. I brought you back in here to see where we're at. I lightly skimmed those 2 surfaces right there to clean them up. Now if you look real close, you can see that there's a contrast of surface difference right there. That's because the gear itself is a hardened piece of iron, and they press in a cast or a ductile bushing, and that's what's made up for a bushing. So it's all part internal. There's some heavy duty oil grooves and oil passages that go through the gear teeth from the outside right there. So I've dressed both of those up. All right, just give you a close-up here of the end of the shaft. The spline section, we machined back 100 thousandths on both sides, and we're going to put a thrust washer on here. We have the washers roughed out in the lathe now, and we're getting ready to assemble this, put this back into the jig, and measure our side to side so that we know how far to part off the pieces, the thrust rings that we're going to create on here. We got to set them over in the surface grinder and grind them nice and true on the side. We're making them out of 4130, and we'll probably quench them before we grind them. Okay. The rings are going to be the diameter of the outside of this and press fit for the surface that I gave in there at the root. All right, now let me show you why I decided to do that. If you look down in there, in other words, right in here, okay, I can almost stick my finger in between there. There's more than enough room, and the splines never travel all the way to the outside edge, okay? So really there's almost this much room, my finger width, the height of this, plus just a tiny bit. So the 100 thousandths is not going to affect anything, and it gives us much more surface contact area, and we can bring those clearances down to what I think they should be instead of that 25 thousandths that it was wearing side to side. It actually wasn't wearing out, it was wearing in closer, so as they were idling. But if you have a closer side to side, then you're not going to have as much of this action. If you leave that action in there, then the bore has tendency to have more air, because the length of the bore is shorter than the diameter of the bore. So it would be important to keep these running in line so they're not gyroing off like this. We assembled our shaft with the gears in the proper position, and we set it up in the lathe, just lightly chucking on it after we preloaded with the tailstock. So we're pushing against this gear and loading it into position. When the bearing races back here, it holds that gear up against the shaft, so that's how it holds the position. Then we've taken our gears and we've thrusted them back and forth in here. This is actually showing I got 15,000, a good 15 thousandths on this gear, and when we flip it around, this other gear, which is, we're calling this the aft gear and this is the forward gear, in relationship to the chuck side and the back side of the lathe. So this thrust dimension here, plus the 100 thousandths that we created off of the spline, is going to be our spacer side to configure to be 0. And then we'll plan on what we want for, and I think 2 thousandths, I'm going to shoot for 2 thousandths max. Let's part off the first one. You can see right in here the spacer ring made up, and it's just as high as the spline top, but it goes on down, gives this whole surface a nice radius to roll on. Okay, in the teeth there you can see the oil groove there. There's another one. Several of them in there. All right. Now let me bring you out. I set this up in the Rutland lathe, and I had the tailstock actually holding pressure against this gear as if it was sandwiched between those cone bearings, okay? So that force is up against here so that the thrust is right in here. I ground each one right to size, and then I could feel a little drag and this and that, and then I just took a 0.5 thousandths until I got the feel that I really liked in here. And I know that there's going to be some good oil clearance, and I know that the gear mesh and everything is going to feel really nice on this new shaft and gear assembly. So I don't know when those gears or that keyways broke and everything went to crap, but I know I'm going to be real happy with it. And that's the way I'm putting this lathe back together, is so that I will be happy with it. 242 on that width, and remember, these are the ones I dug out. These are the ones I dug out of the sheared off. These were stuck into the shaft, so that the gear just sheared them right off. So we're not going to use any of those, so kind of putting them over there on that side. Now these keys here I created yesterday, and I've also installed them already. And disassembled them, and everything's good. I see marks on them. They're making contact, but there's no galling going on, and I didn't gall anything going together and going back off. So the fits are really good. I'm happy with them. All right, gear, thrust washer on the inside, thrust washer on the outside. We're reusing these. I am flipping them over so that they just have a new wear pattern. And the same thing over here. Here's the shaft we're going to use, the keys we're going to use, and the shift cog that we're going to use. We're going to pre-assemble this thing, and I've already done a test run. This gets installed kind of like through the opening without a bearing race and into the race over here, and then we'll assemble the last bearing cone on the back side of the lathe. Then we'll go ahead and the shift fork will get in, and then we're going to rotate down in position. Then we're going to be able to put the shaft through it. So that's the direction I'm going to plan with this. But for right now, I'm going to grab some oil and we're going to assemble this thing. The moment we've been waiting for, all right, I picked up a container here, emptied it out, cleaned it out. This is AW46 hydraulic oil. That's usually what I run in my gearboxes. I've been running the K&T and the Clausing in their entire life with that or similar hydraulic oil. And that's what I'm going to use to spray it. And actually this container is actually kind of cool because I can just kind of squirt it on here instead of the oil can. I'm giving something else a try here. So all right. Looks good. More important than anything else, I just want all areas, all surfaces with a nice coat of oil. And we're assembling this thing, and we want to just make sure there is no dry spots anywhere on it. Okay, and I know it goes in that direction. The dogs, or the cog teeth, I should say, are fatter on one end than the other, and the impression is on the mating teeth they match to, so there is no way to screw that up if you go by the visual. All right, and the next thing, we know that this is the washer or the shim that we made for this side here, and we made them fit snug enough to where they won't fall off if we pick them up like that, right? Okay, we'll put this one on. Okay, it's on there. Okay, our next surface there. And inside all of that. All on that face right there. That's cool. I'm not worried about the whole thing. Around this is where the thrust washer is going to go. Like that. All right. And okay, that one's on there. That one's on there. Now the keys. And I'm so glad I took the time to, what I'm doing is I know that there are marks on here where the key slid. All right. And we know that that dot, we're just going to put that towards that. We're going to reach in here with our tool and make sure that they are in there all the way. We've had it together, and okay. All right. And nice. Okay, now we'll get this next one ready. Okay, now we're going to put the keys in this end here. It took me a long time to get those to fit where they did. I had to stone I actually stoned all the edges on all the surfaces along the spline, the end of the spline, the keys. I did all of that. I went through and I kind of just made sure that everything was clear in here. Okay, and then that punch mark goes towards that as well. Okay, squeeze those keys together, just make sure that they're all the way down in there and they're not air bound or anything. Okay, I felt them go just a little bit. I might have to go over I'm going to go over the arbor press and I'm going to press that one together after I clean my oil. It's more so I got to wipe my hands off so I can run the remote of the camera. Oh, let's bring you out a little bit here. Okay, and this was the end that we just pressed this on a little bit farther. And both of these are spinning nice. Those cogs are just so tight. It's unbelievable for how old they are. And they're not worn. And sometimes a lot of old lathes and stuff like that from people grinding them in, not doing what they're supposed to be doing at the right time to shift their machine in and out of gear. Some people think it's an automatic. When I pulled this gearbox apart, and I ordered every single bearing as I took this apart, so I have everything on hand. A couple of the seals I didn't have. A couple of them I did order, so I'm going to have to make sure I have a few of those. All right, so anyway, on the outside of the bearing boxes, I wrote SIS, and it was like, what in the heck does that mean? So I open up my notes here. Short, intermediate, shaft. Okay, and the bearings are down here, and they are. I marked them number 1, number 24, number 16, the cone and the cup, and their numbers. Okay, and also I have a breakdown. I have several breakdowns, but this one here is an extra one that I can actually just have out here and throw on the bench. Same thing as I have in my book that I made up. I actually have a whole book that's all made up for my lathe. Anytime that I've been interested in anything, I get as much information about it as is. So these are the 2 cones, and those are the cups. Now the cones are both exactly the same. The difference between the cups is the one on the forward side, like I said, that one doesn't move, that one doesn't get shimmed, it doesn't get anything. It has a shoulder on it, it gets pressed in. The other one will slip in the bore on the back side of the machine, and then its flange that seals the outside is shimmed for the preload of the bearings. All cone and cup bearings have got to have a preload. We don't have any idea what they are. We're going to give it our feel, what we think it should have. All right, so we're going to put this into the housing, and each one of these should be ready to slip right on. All right, and we'll put some oil in underneath that as well. And this is the other new one. Little sticky here. I'm gonna wipe this down with some acetone and clean it up, just so I get all that gummy sealer off. This one here doesn't have anything on it. That one there, ready to oil and put it together. Yeah. I'm sure glad that I can assemble this thing like this out of the hole here. And there's that cup, and there's that cup. All right, that's the unit. We're gonna go prep the surface for this to be installed and get this put into the housing, and then we're gonna snake this in and then put this bearing in from the outside. Okay, are you ready? A little bit of a rub of oil here on the inside race. Okay, theoretically, in my dry run, I was able to take this down in here, snake it through. Okay, I didn't have that bearing race on there, or that bearing cone. Okay, I took that cone off. Okay, see, I told you it fit through there. All right, now we'll have to put the cone and the cup on the rear. So now I got to kind of put this in through the opening on the back here. All right, that slid on painlessly. Oh, look at that. And the cup slid right in there. I'm holding it in with my fingers so that maybe it'll stay there. Awesome. Now the big difference is when that cog shifted in there, that would be solid. This would be rolling. All right, so that's how you run this gear. It switches between transferring off of these after these right here are running corresponding with the input shaft here, and then you can shift it over there. And of course, one is a higher gear ratio than the other one. And that's the shaft that was broke, and that's what caused me to take this whole thing apart. And today, it's back together. When I dug out the bearings for that short intermediate shaft there, we came across the shim packs that we cut on the Wazer back with the desktop Wazer. And we still had those cut out, so we have a stack up here. I've got to run down to the hardware store because I want to get some new Allens. And that's what I want to put this together with. And I just want to make sure that we have enough matching and full contact, good not stripped out hexes. You know how it goes. But we're about ready to start fitting this, and we'll shim pack and get the preload on that bearing. All right, I think that's going to call it for this episode. And until next time, thanks for stopping in. Job Shop USA. Get her done.